Hey, I'm Jakub Linowski of GoodUI, and today I want to talk to you about remembering A/B tests. Remembering tests so that we better predict future outcomes. So thank you for A/B Testing Summit for allowing me to host this talk, and I hope you enjoy it. My everyday work, just as a quick introduction, centers around working with numerous companies, experimentation teams, growth teams, to inspire them to run better experiments. And the inspiration kind of works both ways. So sometimes I might try and reference things that have worked for other companies and essentially cross-pollinate. And occasionally some of these companies are also sharing their results back with me to correct my understanding and do a cyclical feedback loop. Okay, so that's kind of every day what I do. Of course, I deal with controlled experiments such as yourself. And if things go well, a couple weeks down the road, we have positive outcomes. A year from now or so, in a grand scheme of things look less pretty than a nice, beautiful, positive win. There's lots of insignificant results. There are negative results. There's actually quite a bit of flat results, and as you know. And then what happens, depending whether it's tens or hundreds or thousands of experiments, depending on different testing velocities and such, we tend to forget. And worse so, we forget in a unbalanced way, in an unfair way. So we have tendencies to remember positive outcomes more so than things that are flat or insignificant, that didn't really do much. And it's an imbalanced way of remembering. So that distorts the picture of what tends to work. And why is memory important? Why is memory of all sorts of our wider set of results key to better prediction? And one of the answers is remembering allows better prioritization. Okay, so if we have Andy here on the left, who has a very strong memory of his full spectrum of efforts, what he can do is, going forward into future experiments, he can prioritize based on these all sorts of evidence that he has, positive and negative and flat, where he can push strong ideas that have worked elsewhere to the top of his prioritization scheme, essentially reusing wins and potentially avoiding things that have lost most frequently at the bottom. Whereas Bob, someone who's more who's a narrower view of or a narrower memory, more of his ideas are balanced and more equal. He kind of goes into experimentation with 50-50 type of probabilities. A second reason why remembering tests is important in such a way is that A/B testing actually takes time, and sometimes we might forget that when we run an experiment, which takes weeks, potentially 2, 3, 4, 6, 8 weeks in certain cases, that's time. That's the price we pay for confidence, for the confidence that we gain from a controlled experiment. Whereas someone who has access to quite a bit of experiments and a solid repository of prior evidence, that person, such as Andy here in this case, is more likely and has more room to make implementation or exploitation decision, where A/B testing is bypassed, is skipped with enough evidence, with enough strong reproducible evidence. Someone like Andy can just flip the switch and roll out implementation decision. And that's way shorter. Similar idea as a third reason to remember having a solid repository of experiments is that once that kind of repository accumulates with a lot of changes, with a lot of patterns, that kind of same idea of exploiting scales. Okay, so someone like Andy could potentially take numerous changes. If there's an opportunity for change B, F, and C, which all have shown some sort of positive probability, there's a potential to do leap experiments. So grouping multiple changes into a single variation, or potentially even making implementation decision based on when rolling out numerous changes in certain situations. Whereas, of course, a lengthy experimentation process where each particular change is isolated for a particular experiment, that stretches the time to benefit from a handful of changes that have shown to work. That stretches that time frame to a way lengthier duration. Okay. And then there's people who might say, yeah, but however, things that work for one side never work for another side. And when such absolute statements are made, that's a perfect sign of underconfidence. It's such people see some sort of evidence and they essentially deny that evidence in an absolute exaggeration. Okay, and on the other flip side of predicting, which is equally distorted, is the statement. Some people might see a particular piece of evidence and say our best practice, and they might make a prediction. Yes, for sure, absolutely, this will work on my side. And it is the other extreme. And it's a perfect example of overconfident predictive statement. And reality is somewhere more in between, where evidence, if we look at patterns and evidence as a probabilities, as a range of likelihoods, I think that's a more realistic way of looking at these kind of remembering these A/B tests and taking them for what they're worth. And sometimes it's good to get out of our own field. Okay, so that's why if we look at a profession that is age old, such as the military, their list of tactics, their list of patterns that have accumulated over a long period of time has grown to a very, very wide range of tactics that can be reused in certain situations. And one example of something like this is the tactic or pattern of suppressing fire in military contexts. And it doesn't provide an absolute certainty that the battle will be won in that particular with such a pattern, and yet it increases the probability of increasing safer movement for friendly troops. Essentially, the idea is with suppressing fire, an enemy is pinned down, and then other teams can move around. Similarly, if you look at another field that's very, very old, such as medicine, washing hands has emerged as a very tactical best practice. And doctors know that. It's not something that will definitely lead to 100% success result of a particular operation or such, nor is it absolutely useless. But it does decrease. It does have it's a multiplier. It does have a probability of decreasing infection rates that can be measured. So if we come back to our own field, our own profession, I wanted to share with you a couple of rules that I go by when I look at a wide range of evidence that helps me come up with patterns and weigh them accordingly. So 4 rules. One of them is to remember all experiments. When we are in a production or product role, or when we're making shipping decisions, of course we have to look at significance, and our threshold for acceptance are high, and we only look at strong, highly significant positive results. But when we're remembering A/B tests, we have to look at a full spectrum, a full range of insignificant results. We have to remember what has no effect, because that is useful information. And equal, we also should be looking at what has a strong negative effect, to potentially weigh down future ideas as such in our prioritization. Another rule that I go by when defining patterns is grouping similar A/B tests together. So one test only provides so much probability or so much predictive strength. But when we have similar experiments that have similar changes and run in similar contexts, when we group them, that becomes a solid content for a particular pattern that we can do some really interesting calculations on. So here we have 3 potential groups of things that have similar changes. And one of such calculations that I find the most interesting is the degree of reproducibility or repeatability. Essentially, how often a particular similar experiment has worked positively minus the times it was negative. Okay, so this is essentially a count of how often that particular change has led to a positive effect, or in certain cases, how often has that pattern led to negative outcomes. And this number is definitely something that could be prioritized, could be used as a prioritization scheme for predicting future outcomes. 4th is being always open to new evidence. So when these patterns get designed, of course, we always have to be ready to take in new information and update our understanding based on incoming test results. And to summarize all this as a particular example of a predictive pattern, I wanted to show you something specific from GoodUI. And this is one of many patterns that we have called centered forms. And the idea is quite simple in that we use, instead of showing something on the peripheral, something smaller, such as forms or calls to action, we use the central space, kind of a larger space, and put more attention to the task at hand by making something larger and more central and avoiding the peripheries. And this pattern is based on a series of tests. So here we have like a summary of how many times it was tested. And this repeatability count is something we just talked about earlier. And this is essentially the key predictive value of that governs like how likely something going to win. So essentially, the more one is derived from one significant test result. And with each time it wins or loses, minus the times it loses, it gets weighed positive or negative. And the more it has won, the more likely we believe it should also lead to positive outcomes. So that's a gauge of likelihood in a way. It's a scale that goes also, remember, it starts with 0. 0 is a kind of a neutral pattern. Anything positive towards infinity is obviously better. Anything negative is a potentially negative pattern that might lead to negative outcomes. More so, we also have a series of metrics for each pattern. So Obviously, different experiments might weigh and measure different things, like shallow metrics like engagement, or deeper metrics like sales and potentially revenue, and maybe in certain cases return visits and such, and referrals. So a full spectrum of meaningful metrics. These, of course, are median effects. They're calculated from numerous tests. So here's one test, and if we actually scroll down, there's additional tests for this pattern. So here's one example where something like this was tested. There was a measured effect. Notice that it was, even though it was suggestive, or in certain cases, some people might consider this insignificant based on its p-value, we still publish that. We still take that result independent of what the result was. And we add that together with a bunch of other tests. Again, the idea here is to get a solid understanding from a wide range of experiments, and find a way to add them up together to increase the accuracy of our prediction. So that's how I remember experiments, so that future experimentation becomes easier with each new experiment that we remember, and find a way to compare and add up and sum up and build the body of knowledge for our profession, so that as more and more experiments are run, we get just a little bit smarter every time. So we've been doing this for probably 2 years or so, and slowly accumulating a series of experiments and grouped under particular patterns. And I want to encourage you to potentially do something similar. Start seeking out these patterns on your own, based on your own experiments. And then maybe there's a selected group that is willing to collaborate, to share. So that's my little call to action here. If you want to learn from whatever I have, captured over the years from numerous companies, I'd love to share it in return for some of your own knowledge. So those are the types of relationships I look for. And if you're open to sharing test data in return for what we discovered, email me. Here's my email address, and I'm looking forward to talk to you. All right. Thank you so much. Thanks, A/B Testing Summit, for organizing this. Hopefully it was useful. And thanks.